So, our goal today is for us to talk about strategies that we can use to divide fractions. Our first question today, and I hope I didn't give it away, but our first question today says, how many 3/4 are in 14? Now, are we going to use addition, subtraction, multiplication, or division to solve this problem? Division. I see Kyler mouthing division to me. Kyler, why do you think it's division?
Because it's, I remember you told me not to do this. I thought before, because it said, can you make a whole number of 3/4 out of 14 wholes? Or 14 wholes. But you told me not to go off the wording, I remember.
Well, not just that word up, right?
Yeah.
Okay.
But you're seeing how many times 3/4 can go to 14.
Yeah. So what would your number sentence be? Or your equation? Your expression, I guess.
14 divided by 3/4.
Yeah, so we have 14 divided up into groups that are the size of 3/4. I would love to hear your strategies for how you solve this. What do you think about solving this problem? Think what you think. Okay, so you're doing like a common denominator algorithm. Is that what it seems like? Okay, so 14 over 1 divided by 3/4. Okay.
And then we have to find the common denominator. So we multiply the 14 once.
So 14 by what?
So 14 once times 4, and I get 56 fourths.
Yes, so let's multiply our numerator and our denominator. So we get 56 fourths divided by 3/4. Okay, keep going.
Then you divide, and 4 divided by 4 is 1.
Okay.
So you got 1 denominator.
Okay. So that basically tells us that we have the same size pieces, right? Okay. So then let's look at our numerator. And keep going.
Well, if you divide 56 by 3, you get
Which we can also write as 56 over 3. Now this one's kind of tricky, right? So this is what I'm going to think about. Well, I know that 3 times 10 is 30. So if I do 3 times, 30 is about half of this, right here. So 3 times 30 is about half of 36. So 3 times 20 would be 60, but that's too much.
3 times 15 is 25.
So I'm going to go down. 3 times 19 is 57, which is still too much. So 3 times, I like that you guys are doing this with me, 3 times 18 would be
6. Wait, no, sorry. I was thinking of division.
I know you are. 3 times 18 would be 54, and then I have 2/3 left over. Okay, so to get from 54 to 56 would give me 2. So there's my common denominator algorithm. Let's also solve this problem with our model. So I'm going to take each one of our pieces, and even though it's missing, this would be 1, and this would be 3. So all we did was to count by, we just showed our 2's up here. Okay? Yeah?
How would it be 18 and 2/4?
How come it wouldn't be?
Yeah.
Can we do our model, and can I show you why? Because that's a really good question. So I'm going to split up each of our wholes into fourths. And the reason that I want to split them up into fourths are because I want to be able to divide them up into groups of 3 of those fourths. So by the time I'm finished, I should have 56 pieces that are the size of a fourth. Okay? So I have 4, 8, 12, and I'm just counting the number of fourths. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, and I have a total of 56 pieces that are the size of a fourth, which up here, for our problem up here, that's what we figured out too. We would have 56 fourths, okay? So the next thing that I'm going to do is to divide this up into pieces that are the size of 3/4. So I have, and help me count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I'm going to stop there for just a minute, okay? Do you see how I have 18 pieces that are the size of 3/4?
Yes.
Now, thank you. Now we have this piece left over down here. And this kind of gets to Jackson's question. What do I have left over? Tatum, what's left over? Okay, I have 2/4 left over. Okay? But I want to know how much of my next piece that is. So do you guys see how each of my pieces is made up of 1, 2, 3/4?
Yes.
And I have 1 2/4 left over. So I have 2 out of 3 of my next piece. So that's how I can get 18 groups of 3/4 and then 2/3 of my next piece. Okay? I am seeing some great models. I see bar models. I see number lines. Way to go, crew. I see some common denominator algorithms. So tonight for your homework, this number line would be considered a model. We'll see some other models today. And then this algorithm, this common denominator strategy at the top, that could be your algorithm. Okay. What questions do you have before we move on? Yeah.
It's what we do it in colors.
Of course you can do your models in colors. That would be so exciting to see. Okay. So here's our investigation today. At the top of your next clean page, I would like you to write what strategies can help you divide a whole number or a mixed number by a fraction. What strategies can help you divide a whole number or a mixed number by a fraction? So our first problem today says Nayla plans to make small cheese pizzas to sell at the school carnival. She has, I'm going to use my close reading strategies, she has 9 blocks of cheese. How many, here's my question, how many pizzas can she make if each pizza needs the given amount of cheese? In order to solve this problem, we're going to take a couple of minutes. So if you have a number 1 at your desk, you are responsible for making sure that everybody at your tribe solves the problem. If you have a number 2 at your desk, you're going to make sure that everybody has drawn a model. If you have a number 3, you're going to help everybody write a number sentence. And if you have a number 4, today you're going to help monitor the voice level of your group. Okay? All right, crew, let's get started. So Finn is going to share his strategy for A1A for 1/3 of a block. All right, go for it, my friend.
Okay, so I had one box representing 1 block of cheese. Then I split them into thirds for each pizza. and then I counted them, and there were 27 of them.
And then tell us about your algorithm.
And then for my algorithm, I did 9 over 1 divided by 1 over 1/3. And then I got 27. Well, when I found a common denominator, I had to multiply the 9 over 1 by 3. So I got 27 thirds divided by 1/3. 3 divided by 3 is 1. And 27 divided by 1 is 27. So then that was 27 too.
Cool. Can I add one thing to your notes here?
Yes.
All right. So this part here tells us that we're dealing with the same size pieces. And then we want to think about doing 27 divided by 1, which we can also write as 27 over 1, which is equal to 27. Since this is just 1/3, hey crew, listen up. Since this is 1/3, it ends up working, but it won't always, to just divide the numerators and divide the denominators. So just be careful of that. Finn, thank you so much. Recording. So Zach is going to share how he got C, which would be 1/5 of a block.
Oh, whoops. I did something wrong here. That looks like it's in the wrong area. Sorry.
Oh, you're fine.
Yeah, that's there. Okay. So for C, I multiplied 5 by 9, and so that would be the I guess 9 holes, and then I divided it by 1/5, and 45 can go into 1 45 times, so the answer would be 45 groups of 1/5.
Nice. What questions do you guys have? Yeah, Jackson?
Did we have to do a model?
You did have to do, yes, for this one. We're working really hard on our models. Thanks, Zach. The next one I want to look at with you guys is this D right here that says 2/3 of a block, because that's a little bit different than our other ones. Who has an idea for how we could start this problem? I would love to see some new hands. How could we start this problem? You see 2 brave students? Tyler, how do you think we could start this problem? We have 9 blocks of cheese and we want to divide them into pieces that are the size of 2/3.
2/3. I'm working on it right now, but
Okay.
I used the common denominator.
Yeah. So what was your algorithm?
27 thirds divided by 2/3.
Okay, 27 thirds divided by 2/3. Now, did this 27 thirds start off as 9?
Yes.
Okay, so it was like you start off with 9 divided by 2/3?
Yeah.
Okay.
I multiplied by 3.
Okay, let me write that a little bit cleaner. So we had 9 divided by 2/3. Then you were getting a common denominator and you did 27 thirds divided by 2/3. Okay.
Alright, and then 2 can go into 27 evenly.
Right.
So that's where I'm kind of hung up. It goes in 13 times.
Okay.
So there's going to be a remainder, but I'm kind of confused on how to write the remainder.
Oh.
The remainder is 1, but
You don't know if it's like what that 1 represents.
yeah.
Nice. Okay, so guys, I'm going to start by drawing a model for this one. So I'm going to start with my 9 blocks of cheese. 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then I'm going to divide them up into thirds because I want to ultimately put them into groups of 2/3. For the very first problem that Finn showed us, he told us that 9 divided by 1/3 was 27. So if we know that we have 9 blocks and we are dividing them up into thirds, so each block has 3 pieces, we could say 9 times 3. Okay, and we could get 27. But this one's different because we're doing groups of 2/3. So here's 1 group of 2/3, 2 groups of 2/3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and here's that 13 that Kyler was talking about. But then we have this piece left over. William, how big is that piece? Okay, it's 1/3. So we have 1/3 left over. However, 1/3 is not going to be our fraction that we're going to use. How much of a piece is this 1/3? Michaela, how much is it?
It's a half.
It's a half of a piece. So our answer would be 13 halves. Now I want to show you guys something. I want to connect this a little bit more to what we saw earlier. We knew that 9 divided by 1/3 was 27. Crew, what connection do you see between 13 and a half and 27?
If you multiply 13 and a half by 2, you get 27.
13 and a half, yeah, it's half of 27. How come that works? Because 2/3 is double what 1/3 is.
Because it's halves, right? It's 13 1/2.
Well,
13 and a half groups of 2/3.
Yeah.
Yeah.
Oh, yeah.
Anthony, what are you thinking? Okay. Vincent, what are you thinking?
Would you like it?
Well, what do you think about the connection here between 13 and a half is half of 27? What do you notice? Why could that be? Why does that happen? So, if our pieces are twice, oh yeah, Jackson?
if you multiply 13.5 times 2,
You get 27, you're right. So look, our pieces here are twice as big. So we are going to have half as many of them. All right. Before we move on, let's look at part B as well. So for part B here, it says, use your ideas. Yeah. Oh, sure.
That one that we just did,
Mhm.
and if it has like similar, I guess, multiple fractions instead of just one, I was noticing that you could combine it just by, you could divide the number of, like, fractions that is like the whole numbers,
Okay.
and then divide it by whatever number is on the.
Oh, you are on to something amazing. So you said, let me go back. You said that we can multiply it by the number of pieces, and then we can divide it by the numerator. Zach, I don't know that you quite know how cool that is that you noticed that, but that's going to lead you to some really amazing things later on. Nice job. And look, guys, if we look at B right here, and we had 9 blocks of cheese, and we divide them into pieces that are the size of a fourth, we could get, how many pieces would that be? That'd be 36, yeah. So we could just multiply it by 4. And then if we divided by 1, we would still have 36. Good observation. All right, we're going to check out B here. And it says, whoops, use your ideas from question A to write questions that the following expression could fit. Then do the calculations. Be sure to label your answers. So our first one says 12 divided by 2/3. So I have 12 wholes that I'm dividing up into groups that are the size of 2/3. So here's my example problem for you. I have 12 bananas, I don't know, maybe for ice cream sundaes or something. And I am going to give each person 2/3 of a banana. How many people can I serve? So, I have 12 bananas.
divide into groups that are the size of 2/3. Now, for me to solve this, yeah.
Oh, can you answer it?
Yeah, do you want to help me?
Sure.
Okay, let's do it.
Alright, so I changed the 12 over 1 to 36 over 3.
Okay, because we want to get that common denominator.
Yeah. And then 2 goes into 36, 18.
Yeah, and then 36 divided by 2 should be 18. So yeah, I could serve 2 people, or 18 people, sorry. But 2 people. Well, if I served 2 people, they would get 9 bananas each. All right, cool. I'm going to let you guys start on B2, and we'll check it in about 5 minutes. Okay, so let's check out B2 together. Hunter, will you help me solve this one? Okay, so I'm going to put B2 right here. I wish you guys could see Anthony's notes because he has organized his paper into sections for each problem, so you can really see where each problem is. It's awesome. All right, Hunter, 12 divided by 5, 6. Let's do this.
So 12 over 1 is third. So we have both fractions.
Okay.
Then we take the 12 over 1 and multiply it by 6, so we have common denominator.
Cool.
And then we get 72 over 6.
Mm-hmm.
And then you can, and then 5 can go into, so 5, 6 can go into 7, 2, 6.
Cool.
A total of 14 times.
Yeah, so then we'll do 72. And this is where I saw a couple of you guys get stuck, which is the same as, 72, not 75. I'm sorry. 72, which is the same as 72 fifths. And you said it goes in how many times?
It goes in 14 with 2 fifths, 2 of 5, 6 from 3.
Nice job. All right, who wants to walk me through number 3? Awesome, will you walk me through number 3?
Okay.
Okay, I'm going to erase this over here. All right, let's do it.
The 12 divided by 7 sixths.
Okay.
Algorithm. And then, wait.
Let's do 12 over 1
Yeah.
divided by 7 sixths. Should we get a common denominator?
Yes.
Yeah, what's our common denominator? Yeah, so we'll multiply our numerator and our denominator by 6. What will we get?
72.
We have 72 sixths divided by 7 sixths. Okay? So now that we have a common denominator, let's divide our numerators. Sound good? So we'll do 72 divided by 7. How many times will 7 go into 72?
10 times.
And what's going to be left over?
2, 6.
2 pieces the size of a 7. All right. Crew, your learning log today is C1. I'm excited to see how you do and to give you some feedback.
Jasmine has 4